Hi everybody, welcome back to class. What we're going to be doing in this video is going over our next topic. The reason we're going over this is even though you've already learned this before while you were probably in a math class, is it introduces and it helps us going into some of our other material like reading graduated cylinders and reading triple beam balances. And it gives us good practice for that, and it is a skill that we need to learn. So we are going over the topic of length. Now, length is pretty easy. Length is the measurement of a distance, or the other way to think about it is how far is it from point A to point B on anything. You could talk about length and that way from like here to Altoona. You could talk about length as how tall is a tree. What's the length from here to here? How tall is the tree? How high is the tree? That's still a length you're measuring. Now, you commonly, right now at least, before this class, commonly measured everything in English units. You measured everything in English units, and that's what you're familiar with. You can visualize what a foot looks like. You can visualize what an inch looks like, what a yard looks like, and you can probably visualize what a mile looks like. These are English units, though, and this is not what we will be using in class. What we're going to be using in class from now on are metric units. We're going to be using metric units. Even though it sounds different, they're a lot easier to learn, and they just take a while to visualize them, to get used to them. Now again, we're not going to be really using English units anymore. And you're used to them, I understand that, but we're not going to be using them. The metric units will be millimeters, centimeters, meters, and kilometers. Now, there are others out there, but these are the four most common ones that you're going to use. But I can make any prefix work for this. Please note the units. Millimeters, it's a lowercase 2m. Centimeters, lowercase letters. Kilometers, meters is just an m. Please note what those units look like. They're very important. Now it also has here where you're using these. Millimeters are really small, and you can read over this. And I'm going to go to the next slide to try to help you out a little more with that. Again, you're used to the English units, and you can see estimations there of what they look like. But I'm going to focus down here on the metric. A millimeter is about the thickness of a credit card, so they're really tiny. Centimeters are that little tiny piece on the end of a pencil, that little metal part, not so much all the eraser, but just that metal part right there. That little metal part is about a centimeter. Another important thing to note is for every centimeter, there are 10 millimeters. Every centimeter has 10 millimeters. The other unit that we're commonly going to be using in class is the meter. And the meter is roughly, it's not exact, but from a door handle to the floor. So it's real close to actually a yardstick. If you look up above, a yardstick is the same, about the door handle to the floor. So when you're thinking a yard, you're thinking roughly a meter. A meter is slightly longer by about 3.5 inches. The other thing to note here is every meter has 100 centimeters. The other thing would be 1 meter has 1,000 millimeters. 1 meter has 1,000 millimeters. And you'll see how important that is later on down the road here. The last thing is a kilometer. And a kilometer is hard to visualize unless you actually see it. One way you can visualize a kilometer is it is 2.5 laps around a track. It's 2.5 laps around the track for about a kilometer. When you're trying to visualize a kilometer, if you come into my class or you go out back in the yard here at the school, right about where my class is, there's that pine tree. If you ever look down the pine tree and you're looking at the wood or towards the woods, and there's a dirt pile down by that gravel where we go for a fire drill. From about that tree down to that dirt pile is really close to a hectometer or 100 meters. You would still need to go 9 times that distance to get a kilometer. Roughly, let's say 10 football fields. It's not exact, but 10 football fields long would be 1 kilometer. Here's the important part about length, is actually being able to read a meter stick. Now, right here is how all the meter sticks are going to look. They're going to go all the way from 0 all the way up to 100 centimeters at the other end. So this is just a very small zoomed in piece. Each one of these little tick marks here, each little tick mark here, it represents, and I'm going to change this up here, 1 millimeter. I'm going to zoom in. So that's 1 millimeter. That's 2 millimeter. That's 3 millimeter. 4 millimeter. 5 millimeter. 6 millimeter. 7 millimeter. 8 millimeter. 9 millimeter. And your 10th millimeter would be right here, but that's just now 1 centimeter. 10 millimeters equals 1 centimeter, as we saw back here on the previous slide. So that shows that. Not only do each one of those tick marks represent a millimeter, they also represent a tenth of a centimeter. And that's where you get 0.1 centimeters, 0.2 centimeters, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and it keeps on repeating then each centimeter. So now this is 1.1 right here. 1.2, 1.3, 1.4, 1.5, 1.6, 7, and it goes on and so forth. Now here's the tricky part about reading these, is when we're looking, and I have it right down here, but I'm going to zoom in right here, is when we look at this piece right here, this is where it gets tricky. Because in here, the number is uncertain. I say this is where you have to guesstimate. You have to kind of guess at what the number is going to be. It's anywhere from 100th, or they're all 100th mark, but 0.01 to 0.09 is where they go for. What do I mean by that? Well, let's look at an example. Down here at this example, right here, right where this line is ending, okay? Right down there on that red line. I say that this line has a range between 2.34 centimeters and 2.36 centimeters. Now, before I go any farther, a very important part about this whole entire lesson is going to be this. For every measurement, you must have number and a unit. You must have a number and a unit. I will take off points if you don't have both. Now, you do not need to do what I did where you have a range. I have a range from 2.34 to 2.36. The reason being is that guesstimation in there. That little bit of guesstimation gives you that range, but you only need to pick one number. Again, let's go over what I mean by that. When I zoom in here, when we're measuring, what we're going to do is just read the ruler. I know that the line went past 1. I know it went past 2. It did not go past 3. So we know it went past 2. That's the farthest it went. Now we're going down to the little tick marks here. We know it went past 0.1. We know it went past 0.2. We know it went past 0.3, but it did not go past 0.4. So our next sure number, the one that we're certain of, is this 3. We're pushing the sig figs to the limit. So we know it went past a 0.3. It did not go past 0.4. Now you have to guesstimate. Now when you're zoomed out, it's harder to read. When you zoom in, it's easier, but you're not going to have the ability to zoom in like I am. If I was looking at this, I'm saying that it's a little closer to this 0.3 side than the 0.4 side. That's why my measurement would say 0.4 centimeters. I'm saying it's not halfway. If it was halfway, you say it's halfway, it'd be 0.3 0.5. That 0.5 means it's halfway from here to here, from the 0.3 to the 0.4. If while we're zoomed out, you say, well, that looks really close, it looks closer to the 0.4, that's okay. So we say the answer is 2.36 centimeters. This last number here, and here is our guesstimation number. We're guessing where it's at. Any one of those three answers would be correct. You just have to pick one that you believe it would be and read it there. Again, it gets easier once we start doing examples. So let's look at some. In this first example, right here, if I was reading this, I'm saying that the measurement is dead on that line. Now, all your measurements are going to need to have 2 decimal places when you're using a meter stick. So I would say this is at 2 point. We're sure that it doesn't go past this. And then we need a guess number. When it's dead on a full centimeter, it's going to be 2.00 centimeters. But again, because you might look at this and you say, well, I'm not sure, it might be a little over the line or it might be a little before. I would accept for this answer 1.99 centimeters to 2.01 centimeters. Any of those would be correct. The answer I would pick, me personally, would be right there, 2.00, because I believe it to be dead on that mark. Let's go to the next one. We have right here on this mark. If you asked me, I would probably say that's pretty well dead on. So I would say, whoops, it goes past the 1 point, and I'm saying it's dead on that 0.1. 1.10 centimeters. But again, you might say it's a little bit before that line. You might say it's a little after. So you could have anywhere from 1.09, which would have been right before the line, to 1.11 centimeters, which is right after. If you had an answer anywhere in there, it would be correct. Let's go for another example now. We're going to look at this one up here. We know it goes past a 2. We know it goes past 0.1. We know it goes past 0.2. So we know the answer has to be somewhere around 2.2. And now we have to guesstimate. If you asked me, I say that the mark is slightly over halfway. I would say that it is slightly over halfway. So I would, but it's close to halfway, so I would probably say 2.26 centimeters. Somebody might say it's halfway when it's zoomed out, so 2.25 centimeters, because we're guessing at this last number between here. Or you say it's a little farther, so we go 2.27 centimeters. So the range on answers, I would have accepted 2.25 centimeters to 2.27 centimeters. Again, we don't need to, you don't need to write this whole range. You're just going to pick one of those 3 answers. You just pick one measurement, because when you're anywhere else in life, you only give people one measurement when they ask for it. Now to the last example, which sometimes throws people. When we look at it, it's before all of the tick marks. It's before all of the tick marks. So we know it's going to be 0.0 something. We have to guess. I would say it's pretty close to this next line, to right here, but it's not quite on top of it. So I would personally say 0.08 centimeters. Some people might say it's a little farther towards the 0, so 0.07 centimeters. Someone might say it's really close, so it's going to be 0.09 centimeters. Again, any of those numbers would be correct. So I would say the range is 0.07 centimeters to 0.09 centimeters. Now, if you wrote your answer as 0.09 centimeters, that is not incorrect. It's the same when we were working with sig figs. It is not incorrect. Now, if you ever ask my opinion about where measurements should be, I'm going to zoom in really close here. When I'm talking, if I'm ever looking at if a measurement is 0.09 or that last little 0.9, when I think 0.9, I'm looking if a measurement is really, really close to that next line. When it's butted up right against, but it doesn't quite cross, that's what I personally consider a 0.09 or 0.19, 0.29. That's what I'm considering when I hit the 9. Or if I say 0.11, 0.21. When I say that 1, they're pretty darn close to the first line. Hopefully these notes help you out. Please use them to complete your notes. You will have practice with measuring length. If you have any questions, please feel free to email me. Thank you, everybody, for your time, and have a wonderful day.